Hello, in this video we are going to review the Edulastic assignment from Unit 1. This is a review and we're just going to go over a few important concepts from Unit 1 and some common mistakes that many of you made. Now again, these mistakes that I've identified and took a picture of to put in this video are good mistakes. Mistakes are a good thing. Mistakes show me and yourself what you're learning, what you might need help with, and they help us determine where we should go moving forward. And again, we learn from our mistakes. Mistakes are good. That's how you learn and become even better at math. The first problem we're going to talk about is problem number 5. It says, which number is a multiple of 7? So many of you happen to select 1. That was very common. And in fact, many of you think that's the first multiple. But really, the first multiple of 7 would be 7. And in fact, something cool about multiples of 7, we're always going to continue to add 7. So we have 7 plus 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. 28 plus 7 is 35. 35 plus 7 is 42. 42 plus 7 is 49. 49 plus 7 is 56. And 56 plus 7, it happens to be 63. Now, if I continued on, you're going to find that you don't get to 89. I see that 17 is not an option either, but in fact, 63 is a multiple of 7. And notice the pattern here. We continue to add 7 to each number, creating all the multiples of 7, which can continue to go on and on. Another trick to help you identify which numbers are multiples of 7 is you can actually do 89 divided by 7, 63 divided by 7, and you're going to find, whoa, 63 divided by 7 happens to be 9. If you get 17 divided by 7, you're not going to get anything. Well, you're going to get a number, but it's going to be a decimal. It's not going to be a nice, easy whole number. And same with 1 divided by 7 is the same thing. That's less than 1. But again, we want a nice, beautiful whole number, which in fact, 63 divided by 7 does give you an answer of 9, proving that 63 is a multiple of 7. My next problem here says find the first 5 multiples of 14. So again, we're going to use a similar concept here. So notice the answers here were 14, 28, 42, 56, 70. But how did they get that? Just like we did for the previous problem, on the side or possibly scrap paper that hopefully you all did this work on, you have 14 as your first multiple. So in fact, 14 would go here for number 1. You're not going to enter in 1, 2, 3, 4, 5. You are listing out 5 multiples, but we're starting with 14. So I have 14 as my first multiple. 14 plus 14, in fact, is 28. Now I'm going to do that again. I'm going to take 28 and I'm going to add 14. And you're going to find that you get 42. And if you choose from 42 and you add 14 again, you're going to get 56. 56 plus 14 is 70, which in fact, that's creating the first 5 multiples of 14. Now you could continue on and do 70 plus 14 is 84, and you could continue, but notice the directions only ask for the first 5 multiples. So it's always very important that you read the directions so you know what you're answering and you're not doing maybe too much work or too little work. My next problem is talking about factors. What are the factors of 24? Now, as a reminder, factors I like to refer to as all the multiplication facts that create that number. So we're ultimately tearing apart 24 and determining what facts create 24. So I like to write 24 on the side, and I go through each digit. So always, for every whole number, 1 is always a factor, 1 in itself. So we have 1 times 24. I also notice that 24 is an even number. So if it's an even number, that means 2 is a factor. So 2 times some number gives me 24, and that is 12. I also happen to know, wow, 3 times 8 is 24. And in fact, 4 times 6 is also 24. And notice here 4 and 6 are really, really close together. So the only other number between 4 and 6 is 5. And 5 times nothing gives you 24. And in fact, you can figure out if 5 is going to be a factor if that last digit in my ones place either ends in a 0 or a 5. So that means 5 is divisible by that number. So in fact, here are my factors. And you most commonly will find that the factors are always organized from least to greatest, just like these answers here. And when I'm looking through them, this one is on the right track. You listed the factors, but you did forget 3, 8, and 4, and 6. Those are, well, you have 6, but you forgot some of the factors. So we're just missing a few important ones here. And in fact, this answer here has all of them. The other ones you are on the right track, and 24 has a lot of factors. So sometimes it's very easy to forget one, which is why I like listing it out on the side to make sure you include everything here. So always, as always, feel free to use your scrap paper to help you with this. Notice there's many factors, so we can classify the number 24 as a composite number because it has more than 2 factors. Now we have what are the first 3 multiples of 9. So again, very similar to what we did in those 2 previous problems with 14 and 7. Our multiples, we have 9, 18, 27, 36. Notice it's consistently increasing by 9, which is why in fact B is the correct answer. So again, make sure you're always reading the directions really clearly. Here it says put a check mark in the box in the table below to indicate whether the number is prime or composite. So we learned in the previous problem 24 is a composite number because it has many factors. And in fact, the composite number means it has 2 or more than 2 factors, while a prime number only has 2 factors, one in itself. So if you're looking at the number and you're looking at it and you're deciding, okay, the only multiplication fact that creates this number is 1 in itself, that's it, then you would classify that as a prime number. So when we look at the number 99, I know 1 times 99 is definitely a factor. But I also recognize, wow, 11 times 9 is also a factor. That's also a multiplication fact that creates the number 99. Therefore, we can classify 99 as a composite number. Now we have 51. 51 is a tricky one, and you're going to see this is commonly used in 4th grade. Many people assume that 51 is prime because it ends with a 1. And just like 41, it is a prime number for 41. But 51 has a factor that many people forget about. 17 times 3. So let's check this out. 17 times 3. 3 times 7 is 21. 3 times 1 is 3, plus 2 is 5, giving us an answer of 51. So that's telling me that, wow, 17 and 3 are factors of 51. So 1 times 51 is not my only factors. We also have 3 and 17, which is why 51 is classified as a composite number. You can also recognize a little trick with that as well. If I was to add those 2 digits together, 5 plus 1, we get 6. And we know that 6 is a multiple of 3. 3, 6, 9, 12. So that's telling me that 3 is going to be a factor of 51. So notice for 41, if I was to add those 2 digits, 4 plus 1, we get 5. And 5 is not a multiple of 3. So that's why 3 is not a factor. And in fact, 41 is considered a prime number. Now, 23 is also a very popular prime number because I know that 1 times 23 or 1 and 23 are the only 2 factors of 23. Now, nothing else can be multiplied to create the number 23. So that's why we're going to classify 23 as a prime number. This one also says list all the factors of 72. Now, right away, speaking about prime and composite numbers, I see that there's so many factors. There's more than 2 factors. So we classify 72 as a composite number. Now, notice here they gave you a factor. So you had to figure out what is that factor pair. So I see 72. So 72 times something gives me 72. So in fact, 1 is the correct answer. Now what's great here is they gave you one of the factors. You have to figure out what is the pair. So 2 times something gives you 72. If you did 72 divided by 2, you in fact would get 36 as your answer. And notice 72 is an even number, so that's telling me that, okay, 2 is a factor. Here I have 24. This one gets tricky, but I do notice that 72, if I add those two digits, 7 plus 2 is 9, and just like the last problem, so 7 plus 2 is 9, and I know that 9 is a multiple of 3, 3, 6, 9, 12, so that's telling me that 3 has to be a factor. So if I'm looking at the pattern 1, 2, 3, 4 here, maybe 3 works, and if you're unsure, you could try 24 times 3 on the side, and you will find that you get 72. Now I'm deciding 4 times something gets me 72, and in fact 4 times 18, and we have 6 times 12 as well, and also 8 times 9. Now a problem like this, it's really important to try and guess and check some of these facts on the side. And you always want to make sure that the entire chart is filled in. And a little hint here is you see the factors given to you are from least to greatest. So when you're determining what would be this missing box here, well, I know 5 can't be a factor because the digit in my ones place is not a 0 or a 5. So if 5 doesn't work, what else is between 4 and 8? Well, your only other options are 7 and 6. So that's where you can kind of start guessing and checking and using this table to help you figure out the missing factors. Here it says, what is the product of 32 times 67? I figured let's use this opportunity to review the standard algorithm. Okay, and I noticed many of you did get this correct, and there are some choices here. We start in my ones place, 2 times 7 is 14. And then we have 2 times 6 is 12, plus 1 is 13. I cross out anything on top. As I move to the digit in my tens place, I add my placeholder 0, my magic 0, showing that I'm multiplying by 10. Now I have 3 times 7 is 21. I'm going to carry my 2. My 1 goes in my tens place. 3 times 6 is 18, plus 2 is 20. Now, last but least, I add everything together. We start in my ones place, 4 plus 0. 3 plus 1 is 4, 1 plus 0, and 2, giving me a final answer of 2,144. And here it says select all the prime numbers from this list. I chose this on purpose for 2 reasons. The first reason is notice there's boxes as your question. That means the boxes means you will always have more than one answers. When you had this problem here, notice it was circles. That means it's only going to be one answer. But when you have boxes, you're always going to have more than one answer. And notice there's 3 correct answers here. And notice again, there's 51. Remember, 3 times 17 is 51. You will see that number a lot. Okay, that's a little trick for 4th grade. They want you to know that 3 times 17 is 51, which is why that's called a composite number. 39. Oh, wow, 9 plus 3, if I add those digits, I get 12, and 12 is a multiple of 3, so therefore 3 has to be a factor. So 3 times 13, in fact, is 39. And 27, hopefully we know that 3 times 9 is 27 as well, making these 3 composite numbers. Now when I look at 19, 1 times 19 is the only multiplication fact that creates 19, same with 7 and 2, which is why they're classified as prime numbers. The second reason I chose this problem is because of the number 2. 2 is a special number to me. 2 is my lucky number for 3 reasons. The first reason, my birthday is July 2nd. 2 is my lucky number because the 2nd of July is a great day. I also love the Yankees, and my favorite Yankee player happens to be Derek Jeter. He is a retired Yankee player, but many of you might know him, and his number was the number 2. And last but least, 2 is the only even prime number. That means no other even number has only 2 factors, 1 in itself. So if I looked at 4, 6, 8, 12, and so on, those are all even numbers, showing me that 2 is always a factor. But for 2, it's very special. It's the only even prime number. 1 and 2 are the only factors. So, and also, you know, July 2nd is a great day and Derek Jeter's awesome. But therefore, 2 is in fact my lucky number, and it's a great math number. So I hope you enjoyed this video and enjoyed reviewing some material from Unit 1.